So in this video, we're going to talk about the product and quotient theorems as they relate to complex numbers. So I figured that the best way to do this would be to just review how we multiply and divide complex numbers, and then we'll kind of build it up from there. Okay, so I recommend that you just pause the video for a second and that you try to multiply this together and then hit play when you're ready. And that'll just make you feel a little bit more engaged with the video. Okay, so I went ahead and I multiplied everything together, as you see here. So I've got all my work. And so if I go ahead and I just try to simplify this as much as possible, this is going to leave me with -6 times the square root of 3 minus 2i. Okay, so remember that. Now what I want to do is I want to take these two complex numbers and I want to put them into trigonometric or polar form. Now, once again, I'm assuming that you've probably just learned how to do that. So I think for practice, you should try to just convert these. And again, it'll just make you feel a little bit more engaged in the video, and then you can hit play when you're ready. Okay, so I've got my vectors. So here's my calculation for finding r for each of these. So I get that r is equal to the square root of 7, and r is for this one, so for -2 times the square root of 3 plus 2i, r is equal to 3 times the square root of 2. So I've got all the work there if you want to see it and review it. And then to find theta, so I've got all my work here to find theta. So for tangent of theta, so when I took inverse tangent of this was a decimal, so I just rounded to the nearest degree. And then for this other theta, so I got -30 degrees, and usually we like to make sure that that's the least positive number, so we add 360 when this comes out to a negative number. And I get 330, so we're going to use 330 instead of -30. Okay, so now I can write these complex numbers in their trigonometric form. So this is the trigonometric form that we want to use. So I just plug in my r's, I plug in my thetas, as you see here. So I've got my trigonometric form, so I'm all happy and ready to go. Okay, so now I can talk about the product theorem. So let's say that I want to take those two complex numbers and now I want to multiply them in their trigonometric form. Okay, so this is going to take a minute. And I think you will get the absolute most out of this if you take a moment to multiply all of this on your own. So try to multiply all of this on your own. And then you can check your work against mine and then hit play when you're ready. Okay, so when I go to multiply this, I take the square root of 7 times 3 times square root of 2. So I get 3 times the square root of 14. So that part I just leave on the outside. And then I multiply the parentheses together. And so here's everything that I get when I multiply all the parentheses together. Okay, so what do we do? So from here, now I'm going to remind you of a couple of handy dandy identities that we are going to use for this problem. Cosine of a plus b, which is this, and sine of a plus b, which is this. Okay, so hear me out. First of all, this plus I squared, we know what this becomes, right? This just becomes a boop minus sine. Okay, so look, I've got cosine 41 degrees, cosine 330, minus sine 41 degrees, sine 330. And that totally follows this cosine A, cosine B minus sine A, sine B. So cool. Okay, we've got that. Next, we've got these parts. Cosine 41, sine 330, cosine 330, sine 41. That follows this other identity. Okay? So these can all be compressed using the identity. So what I end up doing is I rewrite this as, so this part on the outside stays the same. This becomes cosine now of, and I just add up the two degree measures, 41 degrees and 330. And then this other one, this is I times sine of 41 degrees plus 330. And so, okay, so a little space there. So now when I add those together, here's my final answer. Okay. And oh, maybe just one other thing to mention, I could rewrite that in the abbreviated form, which I talked about in the other video. All right, so what do you notice? So when you multiply these together, you've really just added the degrees, which is the theta, or what we call the argument. That's the technical math term for it. and then you've multiplied the r's together, which we call the absolute values. So that's literally what I did, right? I multiplied the two parts in front together, and then I really just added up the degree measures. That's what effectively happened in thanks to the identities. And this is actually a theorem. It is the product theorem. So even though when you probably were first multiplying together these trigonometric forms, you're probably thinking, oh man, this is going to suck so much. Actually, it doesn't really suck at all. It's actually a lot easier than multiplying the rectangular form of a complex number. Because if I have these two complex numbers and I want to multiply them together, I multiply the r's together, and then I just add up the degrees. That's it. And you could write it like this, or you could write it like this. That's what the product theorem says. So it's actually surprisingly easy. Okay. So let's try this. Let's find this product. I think you should test yourself here and see if you've got it. So if you need to, maybe pause this, write this down for a second, write down this form, this part of the product theorem at a minimum, and then try this. And then if you think you've got it, you can hit play. Okay, so I want to multiply, and I'm going to use the theorem. So these numbers in front, I'm going to multiply them together, and then these degrees, check it out. I'm just going to add them together. I can just use the theorem. I don't have to do all the work to multiply this together. That's stupid, right? I don't have to do that. That's the whole reason why we like this, because multiplying everything together is it's a lot of work, and we have the product theorem that says we could just do this instead. Oh, and it's so nice. So we'll just do that, and we get 15 cosine of 165 plus I sine 165, and so I get this or this, and then if I wanted to write that in rectangular form, all I would have to do is then, so these 165 is not in the unit circle, so I have to use a calculator to help me with this. So here's the approximations of those measures, and then multiply them by 15 to get this answer here. So that would be it if I wanted the answer in rectangular form. Okay, so that covers the product theorem. So let's carry on. And now let's talk about the quotient theorem. So first, I want to kind of motivate this again. So I want you to find the quotient here. So to find the quotient, what you're going to do is you're going to multiply by the conjugate, as you see here. So again, I think that this would be best if you actually did the work. This will be a little bit more meaningful as I go through the explanation. So I'd say pause, just try this, and then hit play. So there's everything when I put it all together. Okay, so there's all my stuff all foiled out. So as I continue to work through this, I can simplify my square roots to this square root of 12 becomes 2 times the square root of 3, and then I have to multiply that by this 2 in front here. And same goes here, so I'll continue just to simplify this whole thing. So ultimately what I get is 8 square root of 3 plus 8i on top over 8, and then of course that will simplify to square root of 3 plus I. Okay, so once again, now I want to take these complex numbers and I want to put them in their trigonometric form. And I'm just going to do this super quickly. So I'm just going to show you the work because I assume that you know how to do this. So I would just say maybe pause and just try to find these on your own just to make sure you're good on this, and then hit play when you're ready. So I've got my r's here already. And then here's all my work for my thetas. So I'm kind of quickly going through this, but like I said, I'm just assuming that you kind of know how to do this already. So the trigonometric form of this complex number is written here, and the trigonometric form of this complex number is written here. So I'll flash the work one more time. So there's the work for r, and there's the work for theta if you just want to double check anything. But otherwise, so there's how we get to that trigonometric form. Okay. So now I want to think back to our actual quotient. How can I rewrite this answer? Let's rewrite it in trigonometric form. So once again, I'll just show you. Here's the work for finding r and for finding theta. So just trust me, r is equal to 2, theta is equal to 30 degrees. And so here's the trigonometric form of my answer from earlier. Okay, so here's what I really wanted to do with all of this. So this is what I really wanted to show you. If I take that quotient and put everything in its trigonometric form, so I think this is pretty crazy. So notice I've got 4 square root of 2 over 2 square root of 2, and this just comes out to 2. But what's the relationship now between the degrees? 30, 30, 270, 30. These are subtracted, right? So this is the quotient rule really in action, or the quotient theorem, sorry, the quotient theorem. So, okay, so hopefully you see that connection. So let's go ahead and let's state the quotient theorem. So once again, I have these two complex numbers. So if I divide them, the complex numbers in their trigonometric form. So what you might think would be really terrible is actually pretty quick. So all I have to do is divide the two r's, those numbers in front, divide them, and then I subtract the degrees. Bada bing, bada boom. So I could also write that, of course, in its shortened form. So hopefully you know that. I didn't have enough room on the slide. Okay, so cool. So again, this just makes our life a lot easier. So let's try this. I think you have the theorem. I'll go ahead and put it up one more time if you want to like write it down or anything like that. So I think that you should just test your understanding now and try to find this, like try to simplify this, and then hit play when you think you've got it. Okay, so for me to do this, so I'm going to take 35 divided by 7 and then 45 minus negative 90. So there's the work that's going to go into that. And so this is ultimately going to be 5 CIS 135. And that, of course, stands for cosine of 135 plus I sine 135. But we could just leave everything in the nice abbreviated form. Okay, so now we're going to need a calculator, and I have just 2 more problems here. Same idea. I think that you should just try these on your own just to check your understanding. So I've got one with multiplication, and then I'll have another one with the quotient rule. So give this one a try. Math is not a spectator sport. Hit play when you're ready. Okay, so I multiply the 2 numbers in front together, and then I'm going to add up the degrees. So I get 25.2 CIS 88.3. Okay, and then what about this one? So here's another one for you. This time it's in radians. We haven't really been working with radians lately. So give this a try, and then once again, just hit play when you're ready. This is a really great way just to make sure that you've got this. Okay, so I take 15.42 divided by 5.21, so I get this here. And then I need to subtract these fractions, radian measures. And so I'll get 7 pi over 12, so I can write my answer like this, or I can write my answer like this. And so yeah, so that's it for these theorems. So I think they're actually pretty nice. They make your life a lot easier. So thanks for watching, guys. I will catch you in another video. We are almost done.